Hi, I'm Kenneth Loeb. I'm going to report the radar plotting. So, in this picture, it illustrated the actual radar on ship. So basically, it is set on the night vision or in a night mode. So this blue line pointing north is actual heading of our ship, and this diagonal broken line represents the EBL or the electronic bearing line. If you put the EBL to your target, you will acquire or it is used to determine the range and bearing respectively of objects detected by radar. So the circle broken line and the circle represents the VRM or the variable range maker. In this radar, we can see that there are two VRMs, the VRM1 and the VRM2. So it is an electronic mark or ring that can be placed over any target on your radar display. An on-screen digital readout will let you know the precise range in nautical miles between you and the target. Radar plotting refresher. The USCG requires that radar observer certification be renewed every 5 years. Since modern electronics are so agile, many mariners have not done the actual radar plot in those 5 years intervals. To brush up for the brush up, here is a quick refresher on radar plotting procedure. We'll begin to the Victor triangle. As as is the case with all triangles, this one has three sides. So side E to R represents the true course or the direction, and speed the length of our vessel. So for example, we are on in a time 0000 hours. So it is labeled letter E. And then by 10 minutes we arrive we have been moved for 5 nautical miles, so that would be marked as R. So the true course of E to R is our true course, and the speed is determined by the distance of the E and R. So the second side is E to M. This represents the true course and speed of other vessels. So which means that on our ship it is mark E and the other ship mark M. So if we put line to E to M, so we will get our true course towards the other vessel and also the speed of the other vessel. So lastly, the third side is the side R to M. So this represents the relative motion vector, the direction and speed of the other vessel apparent movement. So the R to M is the movement of the other vessel. So letter E is anchored in the plot. M may and R certainly be relocated, but E does not move. So this will explain the three sides, the E to R, side E to M, and lastly the side R to M. Next, terminology. So these terminologies are used on the radar plotting. So CPA stands for closest point of approach. If the line of relative motion is extended, the CPA is the shortest distance from that line to the center of the plotting sheet, where our own ship is located. If the CPA is 0, we are on a collision course with other vessel. So in navigating, we must check often our CPA towards other vessel, because if our CPA turns into 0, so collision might occur or collision occurs with other vessel. So next term, the RML stands for relative motion line. The NRML stands for new relative motion line. The SRM stands for speed of relative motions. So it is the SRM is the length or the RM. So it is the distance between R to M. The DRM stands for direction of relative motion, which is the direction or the heading of the R to M. Lastly, MX, the position of the other vessel on RML at planned time of evasive action, point of execution. So the radar plotting used to be referred to as rapid radar plotting, with an emphasis on rapid, in order to make the procedure quick, mathematically painless. Contacts are usually observed at intervals of 6 minutes, 12 minutes, or 15 minutes. Calculating speeds and or distances is extremely easy at these intervals. For example, if a vessel is traveling 18.2 knots, that is 18.2 nautical miles per hour. She will travel 1 over 10 of that speed, so equivalent it is 1.8 miles in 6 minutes, so it is 1 over 10 of an hour. So if a vessel has traveled 1.2 miles in 6 minutes, her speed is 10 times that, 12 knots. The table show below the distances traveled in 6 minutes and 12 minutes interval at a speed of 15 knots. So 15 knots is equivalent to 60 minutes. 1.5 miles is equivalent to 6 minutes, and that 3 miles is equivalent to 12 minutes.
Good day, sir. This is Cadet Serafina speaking, and we're going to continue to report our topic about the radar plotting. So after unlocking the terms, what is CPA all about, contact relative speed, contact true speed, and etc., we're going to plot the given sample on our report. So we'll work in a standard of a 6-month, step by step. Your ship is on a course of 345 degrees. Speed is 50 knots. You may note the following radar contact. At 0830 hours, the contact bears 329 degrees at a range of 9 miles. At 0836 degrees, the same contact bears at a range of 6 miles. So, the question is, what will be the CPA? What is the contact relative speed? What is the contact true speed? So, we will find out later as we plot this given example. So, when the range to the contact drops to 4.5 miles, you want to change your course. Contact passing on your port side with a new CPE of 2 miles. So, in that case, what is your ship's new course? So, for the step 1, notice that the plot is a 6-minute plot. Speeds, distances, and time will be based on a factor of 1 over 10 using a maneuvering board or a radar transfer plotting sheet. So, this is the example of a maneuvering board or a radar transfer plotting sheet. So, this is the example. So, as condition, draw a line from the center in the direction the vessel is heading. This represents the heading flasher. In this case, our course is 345 degrees rather. So, we're going to plot the given example here. So, using the maneuvering board or a radar transfer plotting sheet, we're going to plot here. So first, we're going to plot our ship on course which is 345 degrees. So the 345 degrees is here. So 340, then 1, 2, 3, 4, 5. So here is the 345 degrees. So we're going to plot here. So that is your on-ship course, which is 345 degrees. So the following radar contact is 0830 hours. The contact bears at 329 degrees at a range of 9 miles. So in the step 1, the factor of the distances is 1/10, but in this case it is by 2. So 9 miles, I mean 329 degrees here. So here is the 329 degrees. So it is, and the range is 9 miles. So the distance factor here is by 2. So 2, 4, 6, 8. So in between 8 and 10, so here is the 9. So here is your R here. R at 0830 hours. So for the next contact is the at 0836 degrees, the same contact bears at a range of 6 miles. So 326. So the 326 is here. So 320, 25, 26. So here is the 326. So using again the 1/10 factors, but this time it is by 2. So 2, 4, 6. So 6 is your range, or the 6 miles here. So after plotting the two radar contact, you will connect this one. So from the center to your radar contact will be your CPE. You will need to measure that when using your from the center to your radar contact will be your CPE.
So next step is to locate E on the plot. Set dividers for the distance our vessel will travel in the interval of the plot. So in this case, 6 minutes at a speed of 15 knots is 1.5 miles. So parallel the course line of that. So the course line is 345 degrees. So over to R and draw it in backwards away from R. So remember the course is from E to R, and then label this position. So in plotting the E, we must going to parallel this into the course line, so which is the 345 degrees. So after that we will drag this into the R, and then 6 minutes at a speed of 15 knots is equivalent to 1.5 miles. So from R we will set a divider to 1.5 miles, and then we will draw a line backwards, because when remember that the course line is from E to R, so that's why we are going to put the line backwards, and then we label it to E. So for the step number 4, we will going to locate the M, so which is bearing of 326 degrees at a range of 6.0 miles at 08:3600 hours. Now it is possible to finish the triangle and solve for the other vessel's course and speed by connecting E to M. So approximately 146 degrees at 16.0 knots. So now we are going to locate the M. So the bearing of the M is 326 degrees. We will find first the 326 degrees, which is the bearing of the M, and then we all know that every circle in the radar is equivalent, is the ratio is 1:1. So every circle is equivalent to 1 nautical mile. So the bearing of the M is 326 and the range of the bearing is 6 miles. So we are going to have 6 circles. So 1 2 3 4 5 6, and then 6 miles in 326 degrees bearing. So we will mark it as the M. So we are now have the E to M. So for the step number 5, draw a line from R through the M and pass the center of the maneuvering board. This is the line of relative motion, or the RML. So the distance, also first, we will draw a line from R to M and then to the pass to the center of the maneuvering board. So as we can see, there's the line now. So in the intersection, or the distance from the center of the flat of our vessel to the closest point, or the perpendicular on the RML, is what we call as the CPA, or the closest point of approach. So in this case, the CPA is about 1 mile, because as we can see, like I've said earlier, in radar, one circle is equivalent to 1 nautical mile, or 1 mile. So that is why the CPA is about 1 mile. So to measure it, measure the length of R to M to find contact's relative speed. So here it is, approximately 30 knots.
I'm Joey Dodula Perdes, and I'm going to discuss over the next step on how to do radar plotting. And the step 6 is that according to the problem, with the range the contact drops to 4.5 miles, we are to change course so that the contact will pass on our port side with a CPA of 2 miles. The next step then is to mark on the relative motion line, or the RML, the point at which the contact reaches a range of 4.5 miles from us at the center. And then after that, label this point MX, and then from MX, draw a line tangent to touching the 2-mile circle. When we change course, this will be the new line of relative motion, or what we call, or shall we say, NRML. And the next step is to parallel the NRML from MX to M, not to E, not to R, but to M. Draw the parallel line away from M. So as we can see in the maneuvering board, some of the steps are already done. And then next that we have to do is, in order to parallel the NRML, or a new line of relative motion from the position of the other ship on relative motion line at planned time of evasive action, point of execution, or MX to M, all we need to do is that we need the new line of relative motion as a basis to draw the parallel line away from M. And as we can see in the maneuvering board, the new line here, or of relative motion, is already paralleled to M. Lastly is we are going to change our course and at the same time maintaining our speed. So how to do it? So first is to place one leg of the dividers on E and place the other leg on R. And then we have to swing the dividers so that the R leg, remember E never moves because E is anchored in the plot, crosses the new line of relative motion. Then after that, we have to label the point of intersection R1. The direction from E to R1 is our vessel's new course. In this case, the new course is approximately 12 degrees. So our new course is 12 degrees.